Hello and welcome to my channel again. So here I am Suraj again. So in this video we are going to discuss about the next topic on the Fourier series. So we have discussed about the Fourier series, how to represent the Fourier series into the sines and cosines variations, which functions can be used to represent in the Fourier series, and we have discussed a lot about these things. So in this video we are going to do the coefficients of the Fourier series, as the coefficients plays a very important role in Fourier series. So this video is going to discuss about the calculating the coefficients of the Fourier series. So let's start the video on calculating the coefficients of the Fourier series. So here I have written the formula of the Fourier series, and now we are going to calculate this coefficient. Which coefficient? This particular coefficient, an and bn. These two coefficients are very important. That's why we have to calculate. And why it is important? Because it tells about our sign. Suppose that if I put the value of n is equals to 1, it will become sine 1x. But this coefficient tells about the what should be the amplitude phase of that particular sine wave. That's why this coefficient is very necessary. Now move towards the calculating the particular coefficient. So how we can calculate this coefficient? So again, this is a formula. Okay, so multiplying by cos nx, multiplying by cos mx on both sides. It means we have to multiply cos mx on this side also and this side also. So what we obtained is that this will become f of x. Now after doing this, this will become f of x into cos mx is equals to, it is x, so it is equals to a naught divided by 2 cos mx, and here we also have to multiply. So this particular equation becomes a and sine, here is summation and is equals to 1 from infinity, and here it is sine nx into cos mx plus, and here again the summation from n is equals to 1 to the infinity, multiplying it by the constant, it will become b and cos nx multiplying by cos mx. So now this what's the equation becomes. So what we have to do is that we have to do integration on both sides. Integration on both sides with respect to x we are going to do. So what will happen is that now you can observe here that what will become is that it will become the f of x, here integral of f of x. So integral from where to where? From its time period, whatever the time period of this particular sines and cosines or sines cosine variation is, which I will take x naught to x naught plus L, where L represents the time period of that particular cos and sine, and here f of x cos mx. And on a right hand side also we have to do the integration, and when we put the sign of integration here, what you will see is that a naught upon 2 is a constant, so it will just move out from the integration, and here it will be cos mx with respect to dx. I have okay, so here I have not written dx, so it's a small mistake, so dx and plus, here you can see that, so when we do the integration we just remove this particular summation sign. So removing the particular summation sign, what become is that an is a constant, so it will be after, it will just move out from this particular integral sign, and integration from x naught to x naught plus L, and here it's also x naught, from x naught to x naught plus L. Generally the cos and sine Cos and sine, yes, the cos and sine has the time period of 2 pi, I think. So here you can also just remove x naught and integrate it from 0 to 2 pi. But we are here using x naught to x naught plus L, which is also good. So it's not any wrong in this. So an sine nx into cos mx dx. And again here plus, again we remove this particular summation, and after removing this particular summation, and here also there is a constant bn, putting the constant bn after just remove from the integration because it's a constant, and here is cos nx into cos mx dx. So this what our equation becomes. So what we can do after this? So what we are going to do is that, first of all, again we are going to write here is that this become integral from x naught. I will not write x naught and x naught plus L because it will become more complex, and I will here only put the integration sign. So f of x cos mx with respect to dx is equals to, in my previous lecture I had given a chart, or I had told you about the thing that the sine nx and cos nx integration from x naught to x naught plus L is equals to 0 because sine and cos has no relations. So when you do the dot product of sine and cos, it will generally become 0. It will generally become 0. So this particular equation here becomes 0. And here if you can evaluate this particular integral, so this particular integral evaluation, it will also become 0. Why? Because there is a process. So in the next video we will cover that how should we do this particular integral, but for now you will assume that this particular becomes 0. This integration is complex, that's why I am not doing here that. So that the thing is that this becomes also 0, this becomes also 0, so these both terms become 0, and what we left is this particular thing. What we left is about this particular thing. So here we can write bn integral cos nx into cos mx. Okay, so again I tell you about the thing that when we assume that n is equals to m, our this particular integrals become L by 2. L is L, where is the time period, so it will become L by 2. This integral from x naught to x naught plus L, x naught to x naught plus L, and well you will evaluate this integral where we assume that m is equals to n, where we assume that m is equals to n and it is greater than 0, and if there is greater than 0, then this particular integrals become L by 2, L by 2. So now if we write here this particular integral, it will become integral from x naught to x naught plus L, x naught plus L cos x f of x, and here cos mx. So I have assumed m is equals to n, so I will put down here cos nx. Okay, because I have assumed that n is equals to m is equals to bn, and this integrals become L by 2, where L is the time period. Remember, these types of integrals are introduced in the first video, but its exact evaluation that how we can solve this integral is going to be on the next video, because we have to know about that how we solve this particular integrals. So in the next video, the next video is purely dedicated to just evaluate the all the three integrals, that why this big that why I say that this becomes 0, why this becomes 0. So the proof is being considered in the next video. Okay, so now you can see here that we are now in a phase to calculate the coefficients. We're in phase to calculate the coefficients. So what we can write here is that Bn constant can be written as L divided by 2 integral from x naught to x naught plus L f of x into cos nx dx. So now we have calculated our Fourier, how we can calculate our Fourier series coefficients Bn, but how we can find the An? So what we have done is that we multiplied our equations by cos mx and we get this particular Bn constant. Okay, so in order to get this particular An constant, you have to just multiply it by sine mx, and if you multiply it by sine mx, you will get the coefficient a, this particular coefficient An. So you can see that we evaluated the integrals using some of the famous integrals, which I'm going to do the proof in the next video. And after evaluation, we get this particular value, that the coefficient Bn is equals to, sorry, here is 2 by L. Here is 2 by L, not L by 2. There is a small mistake. Here is a small mistake, that 2 will go, okay, this is equals to 2 divided by L, not L by 2. So now we have a phase that we have calculated the Fourier coefficients, and the same process goes for the calculating the another coefficient An, and its importance is very important. When we do the questions related to the Fourier series, you will see that how important this particular constants are, because this particular constants tells us about the amplitude of the particular sine wave, what's the amplitude of the sine wave is. Okay, so that's the importance of the coefficients. So now we have evaluated this particular integral and got the value of the coefficient Bn, and here the coefficient Bn is for this particular cos, and for an we just got by multiplying it by the sine mx. So this is a video where I have discussed about how do we calculate the coefficient of the Fourier series. And in the next video, I am going to do some of the famous integrals used in the Fourier series. It's proof. Everything else. Okay, so I'm going to do the proof of this particular two integrals that I said that it becomes 0 or whatever I said. What's the proof that this integral becomes 0 when we integrate it from x naught to x naught plus L? So this particular integral is going to be on the next video. So thank you for watching my video on calculating the coefficients of the Fourier series, and upcoming video is also very interesting. So thank you for watching my video.